Ready? Let's have b cubed minus 3b squared. B cubed minus 3b squared. So let's get the prime factors of this again. Each term, let's start from b cubed. B times b times b. 3b squared. 3 is prime. B squared. B times b. Let's circle the common. What are those common? B. What else? B also. Two b's. B times b. Huh? B times b.
B squared.
B squared. Right. So your GCF here is equal to b squared. Now, let's write the factors. One of the factors is your GCF. And then, what goes inside? One of your factors, the GCF, b squared. So what goes here? What goes here? Let's divide now. All right, now let's divide h by b squared. What's b cubed divided by b squared?
B.
That's correct. It's b. 3 minus 3 is 1. So b raised to 1 or simply b. How about 3b squared divided by b squared? Negative 3, positive 3. All right, negative 3. So it's b squared is just canceled. So you have b squared and b minus 3. These are your factors. All right, let's try another one. Okay, 58. You have 16, a to the 4th, b squared minus 24, a squared, b cubed. Okay, so let's get the prime factors of each term. 16. Let's factor 16 here. What two numbers will give us a product of 16? You can think of any two, except 1 and 16. You can have 4, 4. How about 4? 2, 2, 2, 2. So we have 2 times 2 times 2 times 2. A raised to 4? 4a's, right? A. B squared, you have b times b. All right, let's look at the second one. You have 24. What two numbers will give us product of 24? We start by any two numbers except 1 and 24. You can have 6, 4. All right, it can be 8, 3 also. Like 6, 2, 3, 2, 2. All right, I can write here now 2, 2, 2, 3. A squared, there are 2 A's. B cubed, there are 3 B's. All right. Sorry, I have to write it that way. Okay. Now, comparing these two, which are common? How many twos are common? There are several twos. How many twos common? How many twos? 4 twos or 3 twos? All right, 1, 2, only 3. A, how many A's common? 1, 2. How many B's common? 1, 2. Now let's write your GCF here now. Okay, so what's your GCF? 2 times 2 times 2? 8. 8 times 8? B times B? All right. Now I want you to notice one thing. When you're looking for the greatest common factor of powers, like this, the GCF here is b squared. Do you see b squared here? Yes, it's there. Now, between A4 B squared and A squared B cubed. Well, your GCF is A squared. Do you see A squared here? B squared is like, do you see B squared here? What do you notice? The greatest common factor is what? The smaller power, right?
2a square,
Yes. B cubed and B squared, between B and B squared, which one is smaller? B squared. So that's your GCF. Between A raised to 4 and A squared, which one is smaller? A squared. Between B squared and B cubed, which one is smaller? B squared. So now I hope you have an idea on how to find the greatest common factor without doing this. Yes? Because you can avoid this step and immediately write your GCF. So this one is skippable. This step is skippable. You don't have to show it, but then for details, I'm showing it. All right. So just like this, 16 and 24. What number divides 16 and 24 without doing this? What's the greatest number that divides 16 and 24? Of course, 8. But the process of doing that is this. But if you already have that in mind, you don't really have to show it. Like I said, this is a escapable step. Okay, but I would be great if you can show it. But like I said, it's optional. So any question about how it become how we got 8a squared b squared? I hope that's clear. Because now we write the factors. And of course, the first factor would be your GCF. We're not only looking for the GCF, we are also finding the factors. Note that the GCF is one of them. So how do we get this? What goes inside is simply the quotient when we divide the polynomial by the GCF. Now what goes here? 16 divided by 8, 2. A4 divided by A squared. B squared divided by B squared. 1. 1, right? It's not canceled. Oh, yeah, the process is canceled, but B squared divided by B squared is 1, all right? And then negative 24 divided by 8. Negative 3. A squared divided by A squared canceled, 1. So it's equal to 1. B cubed divided by B squared. B raised to 1, or simply B. So now these are vectors: 8a squared b squared minus I times and 2a squared minus 3b. So I repeat, that's a squared b squared and 2a squared minus 3b. The factors of polynomial in 58. You have r cubed s cubed t raised to 9 plus r squared s squared t squared. What do you think is the GCF here? Take the smaller power. R is common, S is common, T is common, so that means we have a GCF for the powers R, S, and T. Without doing prime factorization, what do you think is your GCF here? Although we can show that later. Okay, what's your GCF? Between R cubed and R squared, which one is smaller? It's your R squared. So take that in your GCF. S cubed, S squared. T raised to 9, T squared. T squared. So therefore, our GCF is R squared, S squared, T squared. Well, let's show that. Let's show that using the prime factorization. For R cubed, you have R times R times R. It's gonna be a lot of expanding here. S cubed, S times S times S. Wow, T raised to 9. So that means we have to expand this, writing T 9 times. That's why I said a while ago, you can skip this. Imagine if you do this every time. So I'm giving you some strategies to make your solution shorter. And then for r squared, r, s squared, s, and then t squared, t, t. Now you'll find out that your greatest common factor will just be this. R squared, s squared, t squared. So what strategy did we apply there? We simply look for smaller power. Smallest power of them all. R cubed, r squared, r, r squared. S cubed and s squared, it's s squared. T9, t raised to 2, t squared. So that's your GCF. Now, we can show that using this expanded form by putting circles on those common. All right, so how many r's are common? 1, 2. How many s common? 1, 2. How many t's common? 1, 2. So r squared, s squared, t squared. R times r is r squared, s times s squared, t times t is t squared. Or you can skip this and simply look for a smaller power. As long as those powers are common. Don't just simply look at the smaller power. Make sure that you see r in all terms. Do you see r in all terms? Yes, you see r in all terms. Okay, so let us find the factors now. The first factor that we have, r squared, s squared, t squared. So therefore, if we divide the polynomial here by our GCF, then we'll get the other factor. So now let's divide. What goes inside now? It's the quotient. R cubed divided by r squared, s cubed divided by s squared, t9 divided by t squared, 7, 9 minus 2. All right, this is plus, positive, all right? R squared, s squared divided t squared divided by r squared as s squared, t squared. Nothing, 0 or 1? 1. All right, so we have r squared st squared s squared t squared times r s t raised to 7 plus 1. So we are done. Right, so let's prove that the GCF here is 3x squared y cubed by factoring each term here. So what are the factors of 3? It's simply 3, x squared, x, y cubed, y. 9, you have 3, x4, you have 4 x's, y cubed, you have 3 y's, and then z, you have 1 z. Circle those common factors. You have 3. What else? X, 2x are common. Y's, 3 y's. 1, 2, 3. So if you get your GCF here, simply the product here. 3 times x squared times y cubed. Same thing here, right? 3 x squared y cubed. In order to find your GCF, we now divide. Okay, we now divide. I mean the other factor. To find the other factor, we now divide the polynomial by your GCF. So what goes inside as your factor? 3x squared y cubed divided by 3x squared y cubed. 3 canceled, x squared canceled, y cubed canceled. So what's your quotient? 1. Negative 9 divided by 3. Negative 3. x4 divided by x squared. Y cubed cancel. 1. And then z. So you have these factors now. 3x squared y cubed. 1 minus 3 x squared z cubed. All right. I should have not written that there. I should have not written GCF there. Okay. So erase this.